Hello, everybody. My name is Shiju Raju. I'd like to present the case study of this data set called Beers and Breweries. This is the data set that we analyzed for a data science course here at SMU. I worked on this project with my partner, Roger Shagugi, and I'd like to go over the results that we found while analyzing these two data sets. Okay, let's go to the next slide. So we have two data sets that we looked at. One's called Beers data set. It has about 2,410 U.S. craft beers that shows different variables like alcohol content, bitterness unit, what style of beer it is, and all that. There's this other data set called Breweries, and it shows the name of the brewery, what state and city it is from, and there's about over 550 data points in that data set. So we're merging these two data sets and analyzing it to find out if we can gain any understanding on this, and also to answer all the customers' requests. We also wanted to find out if we can find any additional insights that might be value added to the customer. Okay, so next slide. This is showing the number of breweries in each state. Just a quick scan of it, and we can right away tell Colorado came out to be number one with 47 craft breweries there, followed with California at 39. A quick scan of this shows that West Virginia, states like West Virginia, South Dakota, North Dakota, DC, those type of states only have one craft breweries there. So these are some interesting facts we can find while doing a quick scan of number of breweries in each state in the United States. Okay, next slide. So when we looked at the data set, we found quite a bit of missing values. For IBU, we found 1,005 were missing, and ABV, there's about 62 that were missing. So instead of omitting those rows, what we did is we replaced those missing values with the median value of each respective variable. So IBU was, we used 35 as the median to replace all the missing values, where for alcohol content, it came out to be 5.6%. The advantage of doing this is that it will not skew the results while we use the median values, especially IBUs missing over 1,000 values were missing, so we don't want to omit that. Okay, so this slide, this is showing the median ABV and IBU for each state. Here on the right, we can see Maine came out to be have the bitter beer at 61 is the bitterness unit. Where here Kentucky came out to be 6.25% in alcohol content as the median value. And everything else in between, we can do a quick scan here and find out which state of interest you have, and you can find out what the median value for alcohol content and bitterness. Okay, so this slide, this is showing where the maximum alcohol content fell under, and no surprise, we went to Colorado at the 12.8% alcohol content, where Oregon had 138 as the IBU value, and Oregon came out, it has the most bitter beer. Okay, next slide. So this is kind of giving us the summary of all the statistics for the alcohol content distribution. The median value, like we've seen, is 5.6%. The maximum is 12.8% that we've seen here at Colorado, and the minimum is 0.001, and everything in between. So that kind of gives you an idea of how the alcohol content is getting distributed. Okay, so now we look at trying to find out if there's any relationship between bitterness and alcohol content. So like we see here, there seems to be a positive linear relationship. As the bitterness increases, alcohol content tends to increase as well. A possible explanation for this is because we use hops to increase the bitterness, and more hops you use, the alcohol content goes up as well. So that might be a possible explanation why there's a positive relationship between bitterness and alcohol content. Okay, so now we're gonna look into two styles of beer, IPAs and ales, and try to see if they have that type of relationship as well. So here, this scatter plot shows the one in the blue is the IPA. That tends to be more bitter and have higher alcohol content, because this is here in the upper right hand corner, where ale type of beer is clustering around the lower left corner that shows a less bitterness and less alcohol content. But regardless, there's a positive linear relationship that we can see between these two types of beer. Okay, so to further investigate the relationship, we used the K&N method to classify these two types of beer. So here at the left, it's showing what the K values that we use. This is the optimized K value. Somewhere around 18 or so, we will get the maximum accuracy. So that is the K value that we use to classify this. So here's the classifications. 154 ales were classified correctly, and 88 IPAs were classified correctly. So that gives us an accuracy of 85%. That's pretty good accuracy, and our confidence is good because of that, and we have more confidence in our results between this relationship. Okay. Next slide. This is kind of showing we wanted to look at some additional insights. What else can we find from this data? And we looked at what the popular style of beer is, and it came out to be ale at number 1, and followed by IPA. So if you're an investor, you may want to keep these two types of beer because those are the popular, and that's has a customer demand for it. And we also wanted to look at why the other beers are not so popular and see what we can do to increase its popularity. So these are the type of things that this may be value added for an investor to look into. Okay, next slide. And that is it. That's all the results that we found from this case study. Thank you for watching, and have a good one.